I want to put together a simple demonstration of exactly what polymorphism is and exactly what it does. And so this is the simplest example that I could come up with. And we're going to take a look at how to write the code, and then what are we going to see when we run the code. And for my example, what I'm going to do is I'm going to create two classes. We're going to have a dog class and a cat class. And to keep things simple, each one of those things can only do one behavior. They only have one behavior, and that is to make noise. And we know from our understanding of inheritance that if these two classes both have some code and some ideas that they share, like the ability to make noise, that is a good time to maybe collect some of those things up into one base class. And so that's what we're going to do here. We're going to have a base class that we'll call animal. And animal will have all of the fields and what I would say as an object-oriented designer, it's going to have all of the attributes and behaviors that are common to every animal, regardless of species. Okay, so things like it has a height and a weight, and it has the ability to eat and move and make noise and all of those things. So all of those would go into animal, and then each subclass would implement its own version of each of those things. And in our example, a dog makes noise differently than a cat would make noise. So that's what we're getting at here. Again, we're going to distill it down to just the make noise part of that, so we don't have all that other code to work with. We have one big decision to make when it comes time to create this animal class, and it's a hard one to express verbally, but I think animal is a great example of a use for an abstract class in programming, because we are all familiar with the idea of animals. They're everywhere, but there is no such thing as just an animal, something that is an animal but is not also some subtype of animal. In other words, we can't have, I don't know what it would look like, it would be some blobby thing in my imagination. It can't just be an animal, it has to be a horse, or a dog, or a cat, or a bunny, or whatever it is. It has to be some subtype of that. So in programming, what we say about an abstract class is that an abstract class is a collection of code that can't be instantiated. You can't make an actual object out of it. So we can't take this idea of a generic animal and make a generic animal out of it. We can't take an abstract class and make an object out of that. We can only use it as sort of a template or a pattern that we can use to implement something else. And if we again think back to our understanding of inheritance, this is a good example, right? Because we can say that a dog is an animal, or a cat is an animal, so it follows our is a rule, as I like to say. I'm going to take just a real slight diversion here, something I'm not going to stick with, but just to mention, kind of put it out there, the idea of an interface. So we can fit that in here because not all animals are pets, right? Some animals have been domesticated and some haven't. And if an animal happens to be a pet, there are a whole other set of attributes and behaviors that might be associated with those animals, with that animal. In C#, we can't do what is traditionally called multiple inheritance, where we say the cat extends dog and the cat also extends pet, like a pet class. But what we can do to get around that is we can use the idea of an interface. And so we can make an interface called pet, and we can have a dog extend or derive from animal, and it can also implement that pet interface. And maybe the pet interface adds some things like, well, pets have names. And so if something is going to implement, if an animal is also going to be a pet, it's going to have the ability to make noise, but also the ability to, or it's also going to need to have a name. So that's where the idea of interfaces can come in here. I'm not going to demonstrate that in this video, but maybe we'll save that for another video. So again, for the sake of simplicity, we're going to stick with an animal as a base class that's going to be abstract, and then we'll have just a cat class and a dog class extending that. So let's get started creating this code. I like to make my classes using what is called the class diagram tool. Right click on a project name in the Solution Explorer and view class diagram. The only advantage here is that it tends to be a little more visual, and I prefer to think that way as I'm putting this together. And then I get this workspace where I can lay out all of my classes. So I'm going to right click and say add an abstract class. Okay, and my abstract class is going to be called animal. Down at the bottom here with the details, I can add the method make noise. It's going to be type void and public. And I could add, of course, all of the other attributes and behaviors that an animal would have, things like the weight and whatever other properties you want to give it. But again, to keep it simple, we'll stay with that. And the nice thing about this class diagram tool is, as I'm using it and putting together my classes, Visual Studio is generating code to back that up. So if I double click on my abstract class animal, it has made sort of a template for me. And what it does for methods is it just throws an exception. Exceptions are a topic for a different time, but just as kind of a little flag, if I try and use this method, if I try and call make noise, it's going to say that it hasn't been implemented. And so this is where you think, okay, well, okay, we'll make some noise here, right line. Uh-oh, what noise does an animal make? Remember, there's no such thing as an animal. So an animal doesn't make noise in and of itself. A type of animal makes noise. So this is another great example of a place where we probably want to have an abstract method. I don't want to implement what making noise sounds like or looks like or behaves like. I just want to say, hey, if you're going to make an animal, that animal has the ability to make noise. Okay, so I will just add the keyword abstract here. So now we have public abstract make noise. Get rid of the code block. And what I am essentially doing is making a rule that says anybody, whether it's myself or some other programmer, anybody who wants to make a subclass of animal, they have to now implement the make noise method. Okay, it's really useful with teams if you're working on a team of programmers, because the abstract class can set up all the rules that everybody has to follow, and then you can assign different people to make subclasses of that and know that it's going to work on at least a design level later. And for our simple example, that's all there is to an animal. We can imagine that there would be other things here, but for our purposes, that's it. That's the animal class. And we can prove that this is abstract by saying, okay, well, let's make an animal here. Animal, I'll just call it A. So far, so good, right? I can declare a variable, an object of the animal type or class. The problem is if I try to instantiate that, equals new animal. You can't create an instance of an abstract class. That's kind of the point of an abstract class, right? So all we can do with it is declare it. And there's no point in doing that yet. We don't have anything to do with it. So it's time to make some of our subclasses here. Let's go back to the class diagram, and I'm going to add a class called dog. Now, a dog doesn't stand by itself. A dog is a type of animal. So there's our is a rule. A dog is a animal, or is an animal. And so I'm going to use the toolbox here to get the little inheritance tool, and I will draw an arrow. And what it's going to do, if we double click on that, is just set up my heading there to use that inheritance. And right away I have an error, and the error is about that rule that I set up. If dog is going to implement animal, it has to obey animal's rules. And animal's rule right now is that every animal has to be able to make noise. So I have no choice. If I want to be able to compile, I have to implement a make noise method. And I'm going to override the make noise method. And of course, a dog makes noise by saying woof. Now, I can't help myself here, even though it's not particularly relevant. I really don't like this line of code. My belief or my bias about object-oriented programming is that I want to separate what I would call the user interface from the back-end logic. And console.writeline, that's user interface. That's about interacting with the user. I would prefer to keep all of that in my, what I call the driver class, in the main method or in that program class. For our purposes here, this is the simplest way to do it, and I promised simplicity when I started the video, right? So I'm going to just cringe and wish that I hadn't done that, and I'm going to leave it there. So what I've got is a method that when it's called make noise, it's going to say woof, because this is a dog. And we can implement something similar for a cat by making a new class, cat, setting up the inheritance. Again, I could type this code just as easily, but I happen to like this visual tool. Oh, and by the way, notice that when I typed in my code, make noise, it automatically updates my class diagram. So it works both directions. I can make the class diagram and it will create the code. I can write the code and it will update or create a class diagram to match. Okay, so again, I've got that error because, hey, if you're going to derive from animal, you have to have an implementation overriding make noise. So public make noise. So that's our basic coding. We're done, right? I've created my animal abstract class, I've created my dog and cat. Now we need to take a look at how this works and why this is polymorphic. So the rest of my work now happens in what I call the driver in the program class, where our main method is. You may kind of realize in the back of your mind that I haven't really done anything new here. I mean, I've added this abstract class, but this is really just basic inheritance, which we've seen before, right? And we can have an animal class. We could make it not abstract and just make it a concrete class, and then have a dog and a cat as subclasses, and we would understand how that works. It would be no big deal. We could say dog, I'll just call it Rover, equals new dog. And then I can say, Rover, make noise. I can tell Rover to make some noise, and I'll pause the screen here afterwards. And wait patiently. That's not the most exciting thing, and it's also really nothing new. That's not polymorphism, that's just inheritance. We've seen that already. You can imagine me doing the same thing with a cat. But to make this use and demonstrate polymorphism, here's the idea. I had shown before that we can declare an animal, I'll just call it A, but we couldn't instantiate it. We can't say equals new animal. Even if we type it correctly, it doesn't work. Okay? compiler doesn't like that. You can't instantiate an abstract class. But you can make a reference, you can establish a reference to an abstract class like animal, and then you can create an object of a subtype of that, a derived class from that, and it will work just fine. So I can say an animal equals a new dog, and now it will compile. And I can say a dot make noise, and we're not surprised what's going to happen here. It's going to woof. And so this is polymorphism in action. It's this idea that I have declared my type as that abstract class, or the base class. It doesn't have to be abstract. In our case it is. But it could just be a regular concrete class. I define it, or I declare it as that base class, and then when I instantiate it, I use the constructor from the derived class. That's the idea here. And what I can do is I can now change this. How about if we say A equals, and never mind, it's not a dog, it's a cat. Miracle of miracles, we have broken the laws of nature here and turned a dog into a cat. My wife would be happy. There we go. And so now we can see that on line 14, a.makeNoise knows it's a dog, and so it woofs. And a.makeNoise on line 17, a knows it's a cat, so it makes a meow. And so this is my most basic example of, or demonstration of, polymorphism that I could come up with. And I do want to take it just one small step a little bit further, just to show something really useful, or one of the implications of polymorphism that are really helpful. And so let's say we're not talking about just one animal. Let's say we've got a whole bunch of animals, and maybe thousands of animals, and so we don't want to have individual variables to keep track of those. We obviously want to use some kind of a collection, like an array. So we can make an array of animals, not going to be the most exciting array because it's just going to have two. Well, we'll make it a little more exciting. We'll put 3 in there. So we're going to make an array of animals. And we can now, as we've seen, or one of the implications of what we've seen, is that we can say animals 0, so that first animal can be a dog. Okay. The second one can be a cat. And then our third one could be some other type of animal, or since we've only got 2, I'll make this one another dog. And that's great, it works just fine. So I can create a data structure that holds animals, and I can fill it with any subtype of animal, any derived class of animal that I want. And so that's really useful. And this idea of late binding, which means it's not going to decide until runtime which class it really is, that's really useful for us, because we can now do something like, for each animal an in animals, oops, wrong language here as I get confused between Java and C# as usual. I can say an.makeNoise, and every time we go through the loop, it's going to pull out the next animal in our collection, and it's going to call makeNoise. And at that point, that's when it's going to realize, oh, this one's a dog. I need to call dog's makeNoise method. Oh, nope, now this one is a cat. I better get the makeNoise method from cat. And so we can demonstrate how this works. And there we go, woof, meow, woof. And so this is another implication or something you can do with your newfound polymorphism knowledge. And so I'll wrap up the demonstration there.